So this next lesson is on primary trigonometry, and the word or the term primary trigonometry refers to the basic ratios of trigonometry, which are the sine, the cosine, and the tangent ratio. So what trigonometry means? Well, let's look at the word for a second here. The trig part, that makes us think of the word triangle, and the metry part, anytime you see a word that ends in metry means measure. So really trigonometry means to measure a triangle. And what it breaks down to is it's a way of understanding the relationship between the side lengths and the angles of a triangle. So you might think that this is just limited to geometric applications in, say, navigation or astronomy or construction. But the principles of trigonometry actually show up in a wide variety of real-world applications, including musical rhythm, electricity, and lighting analysis. Basically, trigonometric functions, if we turn our mathematics of trigonometry into a function, what we have is a function that is periodic. So it's a function that will reoccur at a certain period. And there are lots of applications that we see in the real world that are periodic. And quite a few of them follow what we call a sinusoidal relationship. And the word sinusoidal, of course, comes from the word sine. So there is a greater application of trigonometry when we start to look at trigonometric functions. Although we don't do trigonometric functions in this course, that's something that you should have an understanding of. So let's look at how we can use trigonometry, and we'll look at this by basically talking about each of the ratios and what they are. So a regular or a right angle triangle has two sides that are kind of smaller, and a larger side that is what we call the hypotenuse. And the hypotenuse is always opposite of the right angle. The ABC triangle we have listed on this page, the hypotenuse is the lowercase b. The angle that's opposite of that hypotenuse is the capital B, and that is a 90-degree angle. It's not shown here to be 90 degrees, but in this case it is, because we're saying that this is a right angle triangle. I've labeled one of the angles with a Greek letter theta, and that's angle A. So that is our reference angle for determining what our trigonometric ratios are. Now the sine ratio is the opposite over the hypotenuse. The cosine ratio is the adjacent over the hypotenuse, and the tangent ratio is the opposite over the adjacent. In this triangle, when we look at our reference angle A, that means that our opposite is A, because A is the side length that is opposite of our reference angle, theta. Our adjacent is C, because the lowercase c is the side of the triangle that is not the hypotenuse, that is next to the angle. And our hypotenuse is B, because the B is opposite of the 90-degree angle. So if that was the case, then our sine, cosine, and tangent ratios for this triangle would be sine of theta equals A over B, cosine of theta equals C over B, and tan of theta equals A over C. So let's say we switch the angle to angle C as our reference angle. Well, now our adjacent and our opposite have switched, but our hypotenuse remains the same. Our hypotenuse is still B. So if our reference angle is C, the opposite is the lowercase c, because that c is opposite of our reference angle. The lowercase a is adjacent to the angle, and of course b remains our hypotenuse. So now our sine, cosine, and tangent ratios are sine of theta equals c over b, cosine of theta equals a over b, and tangent of theta equals c over b. So in order to find an unknown side length, what we first need to do is determine which type of side we know the length of, and which type of side we need to find the length of. So we're trying to determine, do we have the opposite, adjacent, or hypotenuse, and do we need to find the opposite, adjacent, or hypotenuse? That's what we're doing in this, in our first step when we have a right angle triangle and we're trying to find an unknown side. Once we know the types of sides, we can then determine which trigonometric ratio to use. And then you could write a trigonometric ratio equation and solve for the unknown side length. So let's look at this first example. It says determine the length of side A to the nearest tenth of a centimeter. And I have the angle A listed as 23 degrees. I have my hypotenuse, which is 6.7 centimeters. My unknown side length is A, lowercase a. So let's look at what we know from this triangle. We know the angle. The A is our opposite, and the 6.7 is our hypotenuse. So we need to think of our primary trigonometric ratios. Which one involves opposite and hypotenuse? And the answer to that is sine, because sine is the opposite over the hypotenuse. So I write down sine of theta equals opposite over hypotenuse. I replace the theta, the word opposite, and the word hypotenuse with the relevant numbers or letters we use. So sine of 23 degrees equals a over 6.7. And then I rearrange the equation to solve for a. So I get a equals 6.7 times sine 23. And I write down my answer rounded to the nearest tenth of a centimeter, 2.6 centimeters. So now, when our trigonometric ratio equation is in the form where the unknown side length is in the numerator, when we rearrange the equation, it's all we need to do is multiply by the known side length. But if our unknown side length is in the denominator, then we divide by the trig ratio. So let's do an example to show you what that means. So here, example 2 says determine the length of side A to the nearest tenth of a meter. So the side length we need to determine, which is A, is adjacent of the 35 degrees. So A is adjacent. The other known side length is opposite. That 60 meters is opposite of angle B, or the angle 35 degrees. So which ratio uses opposite and adjacent? That would be tangent. So I write tangent of theta equals opposite over adjacent, and then I replace the theta, the word opposite, and the word adjacent with what we know. So tangent of 35 degrees equals 16 over a. And because our a is in the denominator, when I rearrange this equation, it becomes 16 divided by tan of 35 degrees. That gives us 22.850, and then rounding to the nearest tenth of a meter, we get 22.9 meters. So as a little tip, when you write this here, and we see that our a is in the denominator, then it's going to be 16 over tan of 35 degrees. Or it's going to be the known measure divided by the trig ratio. But if I go back to this equation, when I write this, I see that my a is in the numerator, so it ends up becoming my known value multiplied by the trig ratio. So when my unknown is in the numerator, I multiply by the ratio. When the unknown is in the denominator, I divide by the ratio. Lastly, we can solve for unknown angles as well by using what we call inverse trig ratios. So it says here, determine the angle measure of side theta, or sorry, I should say angle theta, to the nearest degree. And to do this, we have to first determine what is this 5.1 and what is this 8.8? Well, the 5.1 is the adjacent to theta, and the 8.8 is opposite, or sorry, is the hypotenuse, because it's opposite of the 90 degree. So I write cosine of theta equals adjacent over hypotenuse, and then I replace those with the 5.1 and the 8.8. And then to write my theta by itself, I have to do what the inverse cosine ratio. So let's show you how to do this on your calculator. First, I would do the 5.1 divided by 8.8 for this type of calculator. And then I can hit equals. And then I should hit the second function button, which is, in this case, this arrow. And then I hit inverse cosine. And I end up with 54.58. And when I round that, I get 55 degrees. So let's do some of these practice questions. I won't do all of them, but we'll do B for number 1 first. So to do this, I have to determine what is that x and what is that 45. Well, the x is the opposite of 58 degrees, and the 45 is adjacent to 58 degrees. So that tells me I'm going to use the tangent ratio. So for this calculator, I have to enter my number first and then press the tan button. So it's my unknown is the x, which is going to be in the numerator, because opposite is in the numerator for tangent, which means that I'm going to do 45 multiplied by 58 tangent. And I get 72 degrees. I'm sorry, 72 meters. Or 72.0 meters, I guess, because it's to the nearest tenth of a unit. Let's do number 2. This one says, I'll do 2C. This says, determine the missing side length for each of the following right triangles to the nearest tenth of a unit. So this is 97 centimeters, which is my opposite of the 71. And the x is adjacent to the 71. So there, I'm going to be using tangent again, because it's opposite over adjacent. But now my opposite's in the numerator, and my x, which is the adjacent's in the denominator. So I'm going to do 97 divided by tan of 71. So my solution, my x for 2C is 33.4 centimeters. Lastly, I'll do 3A, this one here. And for 3A, 36 is the adjacent, 48 is the hypotenuse. So I would use cosine because it's adjacent over hypotenuse. So the adjacent 36 divided by the hypotenuse, which is 48, gets us to this value. And when I find the inverse cosine of that value, I end up with 41.4. And because it's the nearest degree, I would just write 41 degrees. So that's some of those problems worked out. Try the homework, and when you're ready, you can complete the quiz online for this unit.